Welcome to the session today. We're looking at a memory sheet on probability, and we're going to look at three types of probability. One's with Venn diagrams, one with tree diagrams, and one with two-way tables. So let's start off with the Venn diagrams. And we're going to answer this using a couple of questions. So what we want to say is, let's say we've got two classes, and we can have those that do art and those that do biology. So we've got two groups. Okay, got the art students and we've got the biology students. And okay, let's get some data. Let's say in the art class we've got D, E and F, three students, and in the biology we've got D and G. But also we have H that does neither. How do I fill all of this in? Actually, I've got four regions. Okay, so I've got the outer region, which means neither art or biology, so H will go in there. But then I've got these three, and that middle one means that those do art and biology, and I can see D is in both. So D goes there, and now I can see that E and F don't do biology, but they do art, so they must be in this group here. So I put E and F there, and similarly G is in this group here because it doesn't do art, but it does do biology. So what I'm going to say is let's first of all get an understanding of some notation. So if I wanted the numbers that do art or biology, that's our or symbol. So the number that do that, I can do 1, 2, 3, 4. So I've got 4 people that do art or biology. Let's do some probability. Okay, what's the probability to do art or biology? Well, we know there's 4, but it's out of 5. So there you go. But equally, we can do this property of art and biology. That's our and symbol. And so we say, how many do art and biology? Well, I can see there's just 1 out of the 5. And then lastly, we can add the not. Let's look at this one here. Art and not biology. What about the art and not biology? Well, that means I've got those that do art, but they don't do biology. That's 2. So I've got 2 out of 5. Okay, so we have other types of Venn diagram questions we're going to look at quickly as well. So let's just put a box around this one here. Okay, so here we're going to see what happens. How do we actually put the numbers in? So let's have a different type of question. Let's keep to the theme of school, okay, and say there are 10 people. Some do PE, some do DT, and of course some will do neither. So let's get some data. So let's say there are 10 people, and 5 people do PE, and 4 people do DT, and 3 people do neither. And that's important. Okay, if I add all this together, I get more than 10, and that's a bit of a problem. So what do? Well, I know that 3 do neither, and that's a given, so I put that there. 3 do neither, which now means I have 7 people left over. So I have 7 people left over. Put a little 7 in a circle there. But I've got 9 exams, as it were. So that means there are 2 doubling. So I have an overlap of 2. So 2 goes into there. And if I have 2 in that group, all the PE, there's 5 students in there. So if there's 2 in that section, there must be 3 in that section. Similarly with DT, if there are 2 there, and overall I've got 4 studying DT, there must be another 2 there. And then from here you can answer also other type of probability questions. For instance, the probability that you do PE and DT would simply be 2, because that's the and, out of the 10. So that's our Venn diagram questions. What we're going to look at now is, say, let's do some tree diagrams. Okay, so tree diagram questions. Now, some important things you need to know here is that when we do tree diagrams, the sum of the branches that all come from this knot must always add up to 1. So let's have a question, and often they do these with sweets or marbles or whatever. So let's have marbles, 5 marbles in a bag, and let's have, some of them are going to be red. Let's say 2 red, and then let's have 3 that are green. So I know that I've got some red and some green. And what I need to know is the probability here, that if it's the red ones, I've got 2 out of the 5, and the green, it's 3 out of the 5. And the important thing here to remember is actually that they add up to 1 overall, and that's really quite important. So let's extend this idea and see how we can go. So this is the first bit. Now let's assume that they put the beads back in. So then they take it out for a second time. So you could either have gone for the first red and then put it back in, or you could have gone for green, being the first one. But because you've replaced it, and this is with replacement, and that's important, it's replaced. Okay, we then don't change the probabilities, because here, getting a red again is going to be 2 over 5, and getting a green, is going to be 3 over 5. And similarly here, it doesn't change it, it's not conditioned. So getting a red here will be 2 over 5, and getting a green will be 3 over 5. Now, things that you need to remember are the and or rule. So here, the and the or. The and means you multiply, the or means you add. Now you've got to remember that. We've done a lot of this stuff, so this is one thing you need to remember. So it's in the growth green box. Okay, that's kind of really important. So if I now look here, I can see the outcomes is red and red, red and red. Notice that symbol. Here, it's green and green. In the center, it's red and green. And it can either be this route or this route. So effectively, let's put it twice, because there are 2 ways to get there. So I can get red, and the and means multiply. So I multiply these together, so it'll be 2 over 5 times 2 over 5. 2 2s are 4, 5 5s are 25. Okay, or I could do red and green. So 2 over 5 times 3 over 5. 2 3s are 6, 5 5s are 25. Or it'll be the other way around, green first, followed by red. Also getting 6 over 25. And I'll add those together to make 12 over 25. So the or means you add, the and means you times green and green. So that'd be 3 over 5 and 3 over 5. 3 3s are 9 over 25. And notice that if I were to add the 4, the 12 and the 9, I'd get 25. So that's tree diagrams done. Let's move on to our final thing, which is to do with two-way tables. So we're now going to look at two-way tables and see what happens there. So two-way tables, another way of showing how the data can be displayed. And to do this, let's say we have 2 driving schools. We have Mavis and Fred. They both run driving schools. And we have, let's do it this way. So, I have Mavis here and Fred here. Now you can either pass or fail. And this cell down here is our total. So let's say we have 30 people doing this. So here we go, 30 people. And let's say we know that 7 passed with Mavis, 6 failed with Fred. And let's also say we know that in total 16 people went with Mavis. Now this could be the setup, and they could ask the question is, how do you fill in all the other cells? And can you? Well, you can, but you've got to do it in the right order. So you've got to think carefully about this. I know there's a missing gap here. I know that 16 people went with Mavis, 7 passed, which so 16 take away 7 is 9, means 9 failed. Now I can see this row here. So I know that 9 failed with Mavis, 6 with Fred, add those together make 15. I also know that 15 failed and overall 30 people did it, so 15 must have also passed. And then I also know that if 7 passed with Mavis and overall 15 passed, then another 8, 15 take away 7, must have passed with Fred. If I add these together, I get 14, which also adds correctly here. 16 and 14 is our 30. So that's our two-way table. And then we can look at some questions. For instance, the probability that someone passes. Well, here I say I know that there are 30 people, so it's out of 30. And I can see that 15 passed. So half the people passed. But also what I can do here is conditional. So let's just say the question is, passed, given you were with Mavis. So passes, given with Mavis. Okay, now this is quite key. What you have to understand is we're now saying it's just with Mavis. So I'm just going to look at this group here. This is my new group. So it's just with Mavis, meaning it's not out of 30 anymore, but it'll be out of 16. So it's out of 16. And how many passed with Mavis? 7. So there you go. And that's how you use two-way tables. I hope this has been helpful for you. And I'll talk to you again another time.